Hello friends, I'm Factezoo, and just because of this one big reason we haven't been able to send many space missions to Mercury even today. Do you know which reason I'm talking about? Well, let me ask you something first. Do you know how many missions we have sent to Mars so far? Around 30. To Venus? About 22. In fact, we have even sent 3 missions to Pluto, the farthest planet in our solar system. And not just that, we have also sent 2 missions beyond our solar system into interstellar space. But do you know how many missions we have sent to Mercury, the closest planet to the Sun? Yes, you heard that right. Mercury is actually closer to us than both Venus and Mars in many orbital situations. Yet despite that, how many missions have we sent there? Well friends, you might be shocked to know the answer. The story of this mystery begins on November 3, 1973. At exactly 5:47 a.m., from Launchpad 36B in Florida, NASA's Mariner 10 probe was ready to launch toward Mercury. At that moment, every scientist had the same question echoing in their minds: would it even reach Mercury successfully? Because this was going to be the first probe ever to travel from Earth to Mercury using only gravitational assistance without relying heavily on fuel. But surprisingly, after some time passed, scientists realized they had worried for nothing. The probe successfully completed most of its journey. However, something unexpected happened that made it seem like all the effort had gone to waste. During its final flyby, due to running out of fuel, the probe crashed into Mercury at a speed 5 times faster than the speed of sound, smashing into the planet's surface and getting destroyed. Now technically, its main task was to send photographs of Mercury back to Earth, and it did accomplish that. But even today, it is often considered unsuccessful. Why? Well friends, the reason is that probes designed to photograph other planets usually capture more than 25,000 images. But do you know how many images this probe captured? Only around 2,700, and some of those even included photos of Venus. As Mariner 10 approached Mercury, it began facing problems that no other probe experiences when approaching other planets. Because of these problems, the probe kept struggling until its fuel eventually ran out, and it ultimately crashed. So what exactly are these problems that probes face specifically near Mercury? For starters, the Sun's intense heat, its powerful gravity, and Mercury's own reflective surface. Any probe traveling toward Mercury experiences 2 major gravitational forces. One comes from the Sun, and the other from Mercury itself. Now tell me, which gravity is stronger? Obviously the Sun's. That means the probe naturally gets pulled toward the Sun rather than Mercury. In simple terms, anything sent toward Mercury risks falling directly into the Sun. And this is one of the biggest challenges of Mercury missions. However, scientists had already found a solution through extremely complex calculations: speed. Basically, the probe's speed must be adjusted with incredible precision. When it approaches Mercury at high speed, it must avoid being pulled into the Sun's gravity while still flying close enough to capture images. Think of it like a race car on a curved road. The driver must slow down while taking the curve. Similarly, if a probe wants to enter Mercury's curved orbit, its speed must be reduced. Otherwise, centrifugal force will push it outward and throw it away from the planet. But there's a catch. If the speed becomes too slow, the Sun's gravity or Mercury's gravity will pull the probe inward and cause it to crash. And if the speed is too high, the probe will simply perform a flyby and escape without collecting good data. Unfortunately, this is exactly what happened with Mariner 10. During the final flyby, intense solar radiation slightly deflected the probe's path. As a result, it fell under Mercury's gravitational influence. The pull kept increasing until it finally slammed into the planet's surface. And this wasn't just a small collision. The energy released during the crash was enormous. If the same probe had crashed into the Great Pyramid of Giza on Earth, the impact energy would have been powerful enough to completely destroy it. Now with so many difficulties, why do we still want to study Mercury? Why did scientists launch another mission there in 2018? Well, before answering that question, imagine this scene. Something similar happens on Mercury too. On Mercury, the Sun appears to rise twice in a single day. And you might be surprised to learn that 1 day on Mercury is literally equal to 2 years on Earth. That means you would celebrate your birthday twice in 1 day there. But why does this happen? Let's understand it step by step in a simple way. 1 day on Mercury is equal to 176 Earth days. From this you can already guess that Mercury rotates extremely slowly on its axis. Meanwhile, 1 year on Mercury is only 88 Earth days. That means Mercury revolves around the Sun extremely quickly. So Mercury's 2 years equal 176 Earth days, which is the same as 1 Mercury day. This means that on Mercury, 1 full year is basically daytime and the next year is nighttime. Fascinating, right? But why does Mercury behave like this? Well friends, if you truly understand this concept, you're basically understanding Einstein's general theory of relativity. Let's take a simple example. Our moon is tidally locked with Earth. That means the same side of the moon always faces us. This happens because Earth's gravity strongly influences the moon's rotation. A similar situation occurs with Mercury. The sun's gravitational influence is so strong that it significantly slows Mercury's rotation. That's why Mercury spins very slowly. But what about its revolution speed? Why is it so fast? The answer goes back about 4.5 billion years to the formation of our solar system. At that time, a huge disk of gas and dust called the protoplanetary disk was collapsing around the newborn sun. During that time, the trajectories and forward momentum of the planets were already set. You can think of it like a ballet dancer spinning. When the dancer pulls their arms inward, they spin faster. When they stretch their arms outward, their spin slows down. In the same way, matter that was closer to the sun gained higher orbital speed, while planets farther away did not receive that same acceleration advantage. This means planets closer to the sun move faster in their orbit due to the sun's stronger gravity. And that's why on Mercury, 1 day equals 2 years. Now this already proves about 50% of Einstein's general relativity predictions. To test the remaining part, scientists launched another mission called Bepi-Colombo. This mission will study Mercury's atmosphere, its chemical composition, its geophysics, and its evolution. It carries many scientific instruments, including the Italian spring accelerometer. This instrument can detect space-time curvature in extremely strong gravitational fields. That means we can test general relativity with great accuracy near Mercury. At the same time, scientists also hope to answer another mystery: why Mercury's magnetic field is so weak. You see, Mercury's core makes up about 85% of its total volume, whereas Earth's core accounts for only about 20%. Yet Earth's magnetic field is far stronger than Mercury's. If we find the answer to this question, we might also understand why Mercury's magnetic field is stronger near the North Pole. But despite all these mysteries, the Mariner 10 mission still gave us valuable information. During its journey, it sent back many important photos and data. For example, it captured the first high-definition images of Venus, something earlier probes like Mariner 1 and Mariner 5 couldn't do. It also proved that space travel using gravitational assist is possible. Now, what exactly is gravitational assist? I've explained it many times in my previous videos, but here's a quick recap for new viewers. In gravitational assist, scientists use the gravity of a planet or moon like a slingshot. The probe first swings around the planet, gaining speed from its gravitational pull, and then launches toward its next destination with increased velocity. The same method was used with Mariner 10. As it orbited around Venus, scientists gradually reduced its orbital radius, which increased its speed. Then on March 29, 1974, it was directed from Venus toward Mercury. When it finally arrived there, it sent back the very first images of Mercury. And that's gravitational assist. Today, the same technique helped send 2 probes into interstellar space. It also allowed the New Horizons mission to capture images of Pluto. But friends, the question still remains unanswered. Why does Mercury behave in such a strange way? In fact, Mercury isn't the only weird planet out there. There is another planet in the universe whose size is even larger than its own star. NASA has also discovered several other planets that almost seem to defy the laws of physics. If you want to know about all those strange planets in detail, I've made a very interesting video about them which you can watch by clicking here. If you like this video, don't forget to smash the like button. Subscribe to the Get Supply Science channel and press the bell icon so you never miss any future videos. See you next time, friends. Till then, as always, stay curious, keep learning, and keep growing. Until then, bye.